Hi guys, Miss Womack here, solving logarithms. We'll be using these properties you see to the right, laws of exponents and laws of logs. So first we're going to actually use a natural log, and this is one of the ones that gave us trouble when we were in class. It says natural log of x minus 1 is equal to 3. So we want to begin by actually rewriting this natural log. So remember the old drop and swap? Well, just remember to swap when we're working with the natural log. So we'll write the base e, which we see right here. And notice what's in the y is coming next. It's on the opposite side of the equal mark, so I'm going to transfer the 3, and that'll be to the third power, is equal to x minus 1. And you're just one step away. A lot of people had trouble recognizing sometimes they're more simple than you think, and sometimes a little less. Some of them do get a little more complicated. Again, this is simply a number that you can calculate, so I'll leave that to you and your trusty calculators. Make sure you're using your TI-84 to do that. We'll go ahead and move over to this one. Again, we're going to rewrite as an exponent. Anytime you have that option, you want to do that. So we know we have an understood base 10 here. So we'll rewrite it as 10 to the 1/2 power. It's going to be equal to x plus 3. And we will subtract 3 from both sides. And I know that when I substitute 10 to the 1/2 power minus 3, we'll figure out what x is equal to. Again, use your calculator to finish that. So here's another one, and we want to, we do see this plus sign, and we see 2 logs on either side. So we're going to use a property that we just studied, this one right there. Because I see addition, then I know that I can actually multiply the logs that are there. So we'll begin there. 1 is going to be equal to, I'm going to start with my log base 4 and simply multiply using the distributive property. Now we're simply going to rewrite it as an exponent. And I think a lot of people actually couldn't see this. So I think the parentheses help because that's one single number. So we'll rewrite that again using this as our exponent 4. We're going to raise that 4 and swap what we see here. So it'll be 4 to the first power is equal to 6 plus 2x. We'll subtract 6 from both sides and also end up dividing by 2. So again, that's going to be 4 minus 6 is equal to 2x. Divide by 2 on both sides. And we'll find out what x equals. Negative 2 over 2, which actually ends up being negative 1 when simplified. And this next problem, I see that same property again. Same one, must be a favorite. Again, if we see addition, that means we're going to multiply. So I'm going to rewrite that as the log base 10 of t multiplied by t plus 3 is equal to 1. So now I'm going to distribute the t. So I have log t squared plus 3t. Now I like leaving it in parentheses so we can rewrite it. That'll be 10 to the first power is equal to t squared plus 3t. Now I'm putting the tails on it. A lot of times when you're working with a t and pluses, they can kind of run in together, so it's a good idea. So we'll go ahead and actually set that equal to 0, subtract 10 from both sides. And we now see that t squared is plus 3t minus 10 is equal to 0. Now we're setting this up for to factor into two little binomials. Again, you're thinking about what number can we multiply, or numbers can we multiply together to give us 10 and add together and give us 3. Mind the negatives, so we certainly do know that there's a difference in signs. Plus, minus, the larger one being with plus. Did you think of them yet? That's right, they're 5 and 2. You guys are getting faster at that. Now, we actually have to solve those. So it's like we would be setting this equal, t plus 5 equals 0. And what do we know about that? Well, we know t would have to equal negative 5. The same can be said, we're just going to change the sign, or it could also be t could possibly equal 2. One of these is going to be an extraneous solution, the other one is not. So we'll go back to the original equation, and anything that makes it negative would end up being the incorrect one. So I can go ahead and see that t is going to equal 2, whereas the negative 5 will be an extraneous solution. Don't forget, you can absolutely substitute any number that you get back into the original equation using all the tools that we talked about on the TI-84. Good luck, guys.